So I will talk about exceptions and timings for this video. We already know how to write our own functions in R. And now we are going to make our own functions throw an error or warning when it receives an unexpected input. You will define some values, and after that, your function can just throw an error or warning and in here. But please keep in mind that, and let me just add my title first and just say what I mean in here, errors and warnings. So please keep in mind that there's a distinct difference between that error and a warning in R. And that is while an error forces the function to immediately terminate in there, okay? Just stop there. If it sees an error, then it's going to stop there. Warning is different. It's just indicate that your function is being run in an atypical way, but it tries to work around the issue and continue executing. Okay? So if there's an error, your function is going to stop, but if there's a warning there, it is going to push or do its best to run your function in there. Okay? So let's see some examples. Maybe it's going to be much clearer for us to see the difference between an error and the warning in here. I'm going to run a function and the name is warn test. You can just give any name in here. Here is my warn test function. I start with a function in here and my input or argument is x. And please remember that we start a curly brace for a function. And let's say I have an if statement in here. If my x is smaller or equals to 0 in this example, and I want to generate a warning. So you can just use the warning function in here. You want to just give a warning in here if your x is smaller than 0 or equals to 0. That means if you have some negative values or zeros for your x, and then I want to write a warning message in here. Let's say, watch out. You can write anything in here you want. Your x is less than or equal to 0. See it to 1. What does it mean is that if this situation is true, I assign as x1. Okay, and I'm out of my warning, and now here is my return. If that value is smaller than 0, the return is going to be true 2 over x in this example. Okay, and here is my warning test function. I want just R to see my function in here, warn test. And now let's try how it is working. If I have my warn test and give 0, and you will see that the warning message is in warn test, your x is less than or equal to 0 as you write in here. But the result is 2 because if it is true in here, I assign x as 1, then the return is going to be 2 over x in this example. And it is same for all values which are smaller than 0. Let's say minus 100. And it is same in here because your value is smaller than 0. Let's see if my value is greater than that guy in there. Warn test, let's say 10. And this time, I didn't get any warning message, but my function just worked as usual. And what does it mean? It's just returning true 2 over x. My x is 10. Then the answer is 0.2 in this example. So if you are working some ready-to-use functions in R, you may be kind of similar with this warning message. We sometimes see that guys in there. This time you are generating your own warning messages or error messages for your functions in there. Let me also give you an example for an error message. let's say I have my error test function. Here is my test function. You can just name it whatever you want. And my function depends on x. X is my argument. And this time I have the same if statement. If my x is smaller or equals to 0, then what? Then stop. This time it's going to stop. It's not going to work. And I want to write a message for this stop in here. X is less than or equal to 0. And then I terminate. Okay. Now, after that one, if this case is false, my return in here is again 0 over x. So here is my error test. And if my x value, the argument in here is smaller than 0 or equals to 0, then it's going to stop. And here is my message will be seen in the screen. And if not, the return is true, 2 over x. Let's try how it is working. My error test, and let's try with 0. And if it is 0, you see that since we stopped there, it didn't work like in warning. Warning is just keeping working in there. But if you have stop, your function will not work, and just give the error message if you just write it there. Okay. And let's say error test 10, then sorry guys, it is not the error in here. Error in I didn't run the function for R, and so then error test not there, and it is giving the another error test in here, which is could not find function. So first of all, I should run this part. Okie dokie. Now my error test is there, and if I run error test as 0, you will see that my error in here is different now. X is less than or equal to 0, and I just terminated. But if I try my error test as 10, you will see that, and now this condition is false, and this part is just skipped, and I get my return as 2 over x in this example. So in here, sorry for my error in here, guys. Here is the one that is working. And please make sure your function is there before you test it, okay? And so in here, both of our functions expect to have x as positive. And so in one test, if my x is non-positive, the function issues a warning and x is overwritten to be 1, okay? And in error test, on the other hand, if your x is non-positive in there, the function throws an error and terminates immediately there, and it's not going to work. So I'm going to write another function for you guys, and the Fibonacci function. And so let's see. I have another example. So I have my Fibrek, kind of similar to Fibonacci, but not the same one. Now this time, we have another function by n. If that n is smaller than 0, I want to give a warning again. And so I want to give a message in here, assuming you meant n to be positive, doing that instead. So if the user gives a negative value in here, I assume that negative value has to be positive there, and I just convert it for that one. And so that's why I'm saying doing that instead in here. Let's say how I do that. I have my n. If it is negative, I can just multiply it with -1 in here, and then it's going to be positive for you guys, for the users. And my warning is done. And but of course, if n for this condition is false, I should write something for my function, as if I have another if statement in here, n equals 0, we are going to stop. I don't want my function to work for 0 values, and then I will just throw an error message in here, and 0, n is uninterpretable at 0. Okay, here is where it is going to stop. And again, I should continue in here if, let's say, n is 1 or n is 2. Sorry, guys. I will do what? My function will just return 1. It's going to be giving 1 for 1 and 2. And if not, let's see, I'm here. If not, my function works like that. Here is my return. If all the conditions are true, I have my phi break again. That means I am calling my function inside it, n-1 plus my phi break n-2. Here is my function in here. Okay, and guys, so let's just go over it one more time. So in my phi break function, I'm running it with one argument, which is n. If my n is smaller than 0, that means if n is negative values, I'm just throwing a warning message, and then I just convert my n as positive. If my n is 0, exactly 0, then I just stop there. My function doesn't work there. And the n is uninterpretable at 0. If n is equals to 1 or equals to 2, it's going to return to 1. If it is 3 or more, then the function is giving, just calling itself for n-1 plus my phi break n-2. So here is how it is working. I just want to show you how it is working, guys. Let me share this page with you. Here is how it is working. Here is my phi break function. For example, I'm just calling it for 5. Okay, my n is 5. And then it's going to 4 and 3, because please remember that my function is just writing n-1, which is my phi break 4 and n-2, and just plus them. Okay, 5 and my phi break 4 and my phi break 3 in here. And when it goes to 4, it is just checking for 4 minus 1 and 4 minus 2. For 3, let's see, it's just checking for 2 and 1. And please remember that if n is 1 or 2, the values are 1 and 1 in here. And for this guy, it's also 1. And when it goes to 3, my phi break is checking for my phi break 2 and my phi break 1. And these guys are 1, 1, 2. And my result is supposed to be 1 plus 1 plus 1 plus 1 plus and 1 plus in this example. Okay, let's see how it is working. And I just run it. And if I just use my phi break as 5, my result is 5. But let's say I run it as 0, then my function is not working. Okay, because n is not interpretable at 0 for this function in here. But let's say you want to run your function instead of that one, or you don't want to see that error in here. And for this one, you can try different strategies. Let's say I want to use the try function. It is just try a wrapper to run an expression that might fail and allow the user's code to handle error recovery in here. Let's try it. Let's try. I want to use my feedback function again in 0. And instead of 0, I don't want to see that error, because then I just write there as silent. I want to run this function as silent. Here is my first attempt. When I run this part, you see that when I run this part, I try this one, and when I run attempt 1, you didn't see any of my errors in here, like n is interpretable, because we use try and we just silent it in here in this example. Okay, and we are just catching them with this try function in this example. Let's say when I run this one, you are seeing this guy in here, but when you just try this one, you don't see them. Okay. So let's repeat this part one more time. If you just call your feedback function from earlier and pass it to 0, the function throws an error and terminates. Let's see what I mean. Here is what it just throws an error in here. But if you run with this guy with try in here, when you pass that one, you can just write it to an attempt 1 in here. Okay, and in this example, in this line of code, the error has still occurred in here, but the try just suppressed or shrinked the print of an error message to the console, because you pass it the argument silent set to true in here. And now your error is in this attempt 1. You see that one? Your errors are here, and now it is stored in the object attempt 1, and which is the class of try error. Okay, you can simply just print that attempt 1 to your console and just see your errors in here. This is another strategy. And so if at the same time, if you just pass a function to try, and if it doesn't throw an error, then your try has no effect and you just get your normal return. Let's see what I mean. I have another attempt. Let's give it a name as 2. And I want to try my feedback function with a value, let's say 6. And if this silent is true again, and when I run this part, you just run your attempt 2, you will see that now you get the value for my feedback 6, like the same one, because it doesn't have the error there. Sorry, 8 in here. Okay, we can try this example in a body of a function in here. Let's see what I mean. I just copy and paste this part. Here is my function. It didn't work, guys. Let me write this part. My feedback vector this time. I have another example. My feedback vector. Now I have my function for an vector. That's right. I'm just defining an object inside my function, and it is going to be length of my vector in the argument. And I want to define a vector, the name is result, let's say, and I want to just, I'm going to just write my results in this vector from n terms times. And let's say we have a for loop in here. My I in 1 to n terms. My result I equals to my fibreg. I'm just asking my fibreg function inside in here, and for each values of I just call my fibreg function inside this vector. Okay, so this function is just first of all getting this n vector and just finding the length of the vector and just save n terms object in the global environment, and then generating a vector of zeros in here, and we will just save each values of for loop in here to this result vector. This function just use a for loop to work through n vector elements by elements and computing the corresponding Fibonacci number with the earlier function my fibreg. Okay, and let's see how we can work in here. I have my foo function, and I want to, I have my foo as an object. I'm going to call my fibreg vector function I defined. And now my n vector is, let's say, I want to run this one for 1, 2, 10, and 8. And as you may remember, my fibreg function, it is good to go with all these values. Let's run this one first. Sorry, guys. I need to write I here. Okay. When I run my foo for all of them, and so my result is my fib vector, my fibreg. I have my fibreg in here. My fibreg, my n terms, rep 0, result, my fibreg, n vector I. Why not? Come on. Attempt 1, attempt 2. Why it's not.
Return'ı yazmayı unutmuşsun.
So we forgot to write this return in here. Return result. There we go. And I just run this part one more time. Now, this function is going and checking for each values in here and run my fibreg function for all of them and save the results in this vector and return the values for us. We have 1, 1, 55, and 21 as results since we have 4 values of this guy. But suppose there's a mistake and one of the entries in vector ends up being 0. Let's see what I mean. I have another example for bar. And again, I'm calling my fibreg vector in here for different values, okay? And my n vec is, let's say, 3, 2, 7, 0, 9, and 13. We have different values, but please remember that if the value is 0 in here in my fibreg, then it is going to stop there. Let's see how it is going to work. So in this example, there's a mistake, and one of the entries, which is 0, in n vector ends up being 0. When I run this guy, you see that it is just throwing an error for us and doesn't run this one. But the intern call to my FibRec in here is just throwing an error when it's CN as 0, and it's just terminated in here and not executing my FibRec vector. Okay, I didn't get anything in here, and the entire call just failed in this example. Maybe we can try something else for our function and try function in here. Let's see, I have my FibRec vector. Now I want to add try in this example. And I have everything almost same, but this time in for loop, I'm just adding one attempt. Let's say I have my attempt, and then I will use try in here. And let's say my FibRec for n vector for each values of that guy. That means I have to add I in here. And then I'm going to have my silent as true. You can just T or true, okay? And so let's say in here, if your class of attempt is try error, please remember that if there was an error in there, the class was something like try error, and the result I, let's say I have my result I in here, is going to be NA, and it's not giving anything in here. Else my return is going to be the result of my attempt in here, and it's going to result in here. So what we have done in this example, I'm just adding an attempt inside my function, and instead of running my FibRec function directly like in this example, I'm just running it by using a try function and it as silent as true. Okay, if it throws an error and I'm returning an NA, if not, the result is going to be the result of my attempt in this example. Let's run this guy. And let's say I have my, I can just try this guy one more time. Remember that for bar, it didn't work. Let's say I use bus and another example. This time I want to run my FibRec try by using the same vector values in here. 3, 2, 7, 0, 9, and 13. Now this time, I'm expecting to have a result in here. Since we add this guy, you see that we have 2, 1, 13, and error in here, and 13 and 2, 32. But I was expecting to have like a vector with NA value in here. Why didn't it work? And my FibRec n terms, and for I in 1 to n terms, I'm attempting try my FibRec function with n vector, and silent is true. Let's write as true, make sure. And if my class of attempt, yeah, just try error in here, my result is NA. Else my result I is NA. Else my result I is attempt. And I'm going to return my result. Why it's not working? Oh, so instead of this one in here, I guess it is just looking for this stop error in this example. Yeah. I wanted to throw an NA value. So it looks like I made a typo somewhere in here. When I run this guy one more time, let's see, it's just giving me the result for 3 to 7 and NA for 0 and 9 and 13's result in here. Okay, they are same like in previous one, but the shape of the output is different when I run like this one. I think I made a mistake somewhere around here. Okay, and now maybe if you are absolutely sure that you don't want to see any warnings for your examples, you can also use suppress warning for your functions. Let's say what I mean. I want to use my feedback function again for a negative value. Please remember that it was just giving a warning message for you. For -3, it is still working, because if it is negative value for my feedback, and it was just converting the value to a positive value in here. And if it is -3, it just converted to 3 and run this one, but still just throwing this warning message for your function. If you do not want to see that warning, you can just write suppress warning, okay? And that's my feedback -3. And you will see that it's going to write the results of your function, but didn't give you that warning message for your example. Okay. So now I will move to another topic, progress and timing. And we will see some textual progress bar for our R code in here. And it's going to be our last topic for today, after just measuring the completion time in here. Okay. And so you may make R pause for a specified amount of time, like in seconds, before continuing. Let's say if you use silent sleep as part of system sleep and 3, you will see that it just sleeps for 3 seconds for you guys. Okay. So when you run this code, I just pause for 3 seconds before you can continue using your console. And we can use that to generate some different functions. Let's say I want to write a sleep test function. And here is my function in here of n. And my result as, I get my result as 0. And I'm just generating a for loop in here for I in 1 to n. Let's say my result is result plus 1. Okay. And for each of them, I want to just sleep for, let's say, 0.5 seconds, half a second. Okay. And the return is going to be return of my result in this example. Let's see. I just run my sleep test. And if I try my sleep test in here, let's say for 8, you will see that it is sleeping somewhere in here. And let's say if you do not run this part, and it is going to be really fast for you. But if you add a system sleep for your example, it is just running slower. And so in some cases, you may want to track the progress of a function as it is executing, okay? And then you can just implement a textual progress bar with like 3 steps. First of all, you initialize the bar object with text progress bar. You can update the bar with set text progress bar and terminate the bar with close in here. And let's see, let's generate a function, and we will modify the sleep test to include those 3 comments in there. I want to generate a progress test function in here. Here is my function for n. And it's again start with results of 0. Okay. And I want to add a prog bar. Here is my bar. Instead of that one, I should write prog bar. Okie dokie. I will use txt progress bar for this one. The minimum, let's say, is 0. And the maximum is n. And the style is 1. And let's say your character in here is going to be equal sign. You can just play with this part, guys. And I want to again add my for loop in here, the first one, this, like the previous one in sleep test, 1 to n. Let's say we are having like just a summation of result with 1. Okay. And I want my system sleep for 0.5 seconds. And I want to set a txt progress bar, which is going to use that prog bar that we defined before. And the value is going to be for each I. Okay. And you should just close your prog bar in this example. And your return is going to be result. Here is my function in here. So before our for loop in this example, we generated or we created an object in here, okay, by calling txt progress bar with 4 arguments. The minimum and maximum arguments are just numeric values that just define the limits of your bars. It's going from 0 to n. You will define the n for your function. And we set the maximum values of that n, which match the number of iterations of the impending for loop in here. N is our number of iterations for loop. And the style argument in here, you will see that style as 1 is going to be integer, either 1, 2, or 3. And the char argument is just character string. It is generally a single character. And it is just defining the appearance of your bar. For example, if you set that bar as 1 in here, and the bar will simply display a line of char, but we add this guy, and for each of them, it's going to just show this series of equal signs in here. And when this object is created in this example, we have to instruct the bar to actually progress during the execution with a call of set txt progress bar in here. And we just pass it in the bar object to update prog bar, and the value should update in the case of I for each value of I in here. And once it's completed, or after exiting, just closing the loop in there, and you have to just terminate your bar with a call of close prog bar, and we are passing it to prog bar in here. And we import and execute prog test, and you will see the line of equal signs in here. Let's say what I mean. I have my prog test function. I want to test my function with 10. And when I run this part, you will see that for each loop, I'm able to see my progress in here. Sometimes it is important for us, guys, okay? It's important for us to see how my for loop is working, how fast for each steps, and then we can play with our function by seeing the progress in there. And after that, we may just change some parts if it is taking too much time. Before closing, I want to show you a very brief topic and it's going to be last topic for today. We will just measure the completion time in here. Okay, so if you want to see how long a computation takes to complete, we can just use system time, which is very easy to use. System time in here, it is going to give you the time of now in here, and we can just let's say highlight all 4 lines and execute them in the console. Let's see what I mean. I have my T1, which is my first time. I want to just see the time in there. Okay, and after that I want to sleep for a while. Let's say sleep for 3 seconds, and for the second time I want to again see what time there. Okay, and you want to see T2 minus T1, the time difference in here. Okay, and let's see. I have my first time, and I want to sleep for a while, and I want to see my second time, and I want to see the difference. Just highlight the whole part and execute them. You will see what I mean now. Okay, and now R is giving time difference of this 3 seconds in here. It is also important for us, guys. Just we want to see sometimes how much does it cost to run a function for our computer in here.